Hello guys, this is Chirodip once again and you're watching Core Java tutorial. This is the part 18 of this tutorial series, and in this part we're gonna learn about how to use non-static member of abstract class. How can you access them, those non-static members. Now the rules are very simple and very easy. First you have to make a subclass of that abstract class. Now after the creation of that subclass, make sure that whatever subclass you are creating of that abstract class, that class should be concrete. Okay, you have to create a concrete subclass, and you can just access the subclass by creating the concrete class particular, and you can implement all abstract methods of that abstract class. And if you can extend those abstract classes in your concrete class, then all the methods and variables will be there in your concrete class. Finally, create an object to that subclass and start accessing members by abstract class through that reference variable of concrete class, that is the subclass. Now for this theoretical concept, let's have a look in this particular code. Now I have created one abstract class A over here, and one abstract method, that is test1, and another method, that is a concrete method, and I have println statement I have given, and test2. So I have created one class, that is a concrete class. Here you can see this is a concrete class F, which is extending the abstract class A. Now I'm just overriding the method test1 over here, and I'm just giving one println statement test1. Now I'm creating the object of my concrete class, that is a f, in my main method. So if f1 equals to new f, object can be easily created, and through that I'm accessing test1 method and as well as test2 method. So in this way you can access those non-static member, and if you run this program you will get an output like test1 and then test2. Okay, so this is pretty simple. Now moving back to the next program, here also I have created three methods, that is abstract void test1, abstract void test2 and abstract void test3, and all these methods are overridden in my classes, in my concrete classes over here. Now I have created another abstract class H, which is extending the abstract class B, and I have overwritten the method test2. So it can be possible, it can be easily possible, because abstract class provide you to extend any class. This is also a kind of class, as you know, and you can extend those classes and you can override them in your class. And make sure when you are overriding that abstract keyword is not there. So I have omitted the abstract keyword, and I have just overridden test2 method in my H class, and again I am extending my H class to my class I, and again I am overriding test1 and test2 method of the main class B. Now in my manager class, I am creating the object of this concrete class I, and I am calling one by one test1, test2 and test3. So it will run automatically. If you run this program, you will get an output like this: test1, test2 and test3. Now moving forward to the next program, here you can see that I have created one class abstract, and I have defined one method test over there. Now I'm creating another class manager3, which is containing the main method. Now I'm trying to create one reference of the abstract class. So you can't create object of any abstract class, but reference can be created. And now here I am creating reference a1 equals to null. So I am not defining the object over here, I am just creating reference. So we can create reference variable to abstract class. Here we are just choosing a as a data type. So a1 is a reference, and which is a data type of a, and but we are not creating object of classes. So this will compile very successfully, and no output will be given, but this will compile very successfully. Now moving forward to the next program, and this is a pretty long program. Let's have a look. I have created one abstract class S, and I have not given any sort of methods or variables or anything in that class, and I have created another class T. So and also class T is having no methods or no variables or something like that. Now again I have created another concrete class, class U. So in this class we are having one particular object to create, that is we are just creating one reference of the class S, that is the abstract class. Over here we are creating the reference. So test1 method is used an argument to a method. Okay, so it's taking an argument s1 which is a type S, and test2 method is also taking two arguments s1 and t1. S1 is a type S and t1 is a type T, and class U is having its own method test3. All are its own method, but test3 is having the by default method, and we are calling ss1 over here, and from test4 we are calling ss1 and tg1. Now test5 method is a method of type S. Okay, this is a S type method, and it is catching one object of S, and the object will be returned from here. Again you are just creating one method test6 which is a type of T, and the argument over here is passing T obj. Okay, so you are passing the reference, sorry, you are passing the reference of T abstract class, and the reference will be return obj, and T test7 is also you are creating, and it will return null. So if you just run this program, it will automatically compile, and according to your requirement you can call all this method and class U over here. So we have not, remember friend, we have not extended any of this S or T class in my U class. Okay, but still we are able to just write the code as above, because abstract class can be useful of such coding, and it's actually basically not 100% abstract. For this you cannot call abstract 100% abstract. Why? Because you will get to know in next video, next tutorial, I guess. So abstract class is not 100% abstract, but here is the case that you can just access those reference variables in your class, that is your concrete class, and whatever methods or variables you have declared, that can be set as a type of your abstract class type. So it can also be possible, and it is very useful to when you are using abstract class. Now coming back to the next program over here, you can just see that this is a very good example. Actually this is a very good example of just creating an abstract class, but it's taking that abstract class is watching that you can watch that abstract class is not 100% abstract, but you will tell me that how can it be possible. So I have given one example over here. Through this example you can see that abstract class is not 100% abstract. It's a pretty contradictory statement over here, but abstract class is not 100% abstract. In Before going to this program, let's tell you a little bit thing of this particular program. In this program actually, sorry, in this program actually class U is not a subclass of the class S and T. Okay, you have to just remind all these things. Class U is not a subclass of S and T, because we have not extend S and T. And argument to a method or constructor we have used over here, we are using S and T for data type purpose over here, and this data type purpose, these all are data types. Okay, ss1, ss2, tt1 is, these all are data type purpose. So we are using this data type purpose in the form of arguments, okay, to a method or constructor. If you are declaring one constructor of class U, so you can pass the argument of S type and T type also over there. And local variable inside a method or constructor, IIB, SIB or constructor is not allowed. Okay, and return type to a method should be there. So this is the primary concept of this whole scenario. Now moving to the next program. This is a program that will illustrate you that abstract class will not 100% abstract. So how it will happening, let's have a look of the whole program. Now I have defined one class X over here, and X is having its own constructor, default constructor, and I'm just given one println statement over here. Now I have defined one another method test over there in the class X, and one concrete class over there, that is a class V, which is extending class X, and V is having his own constructor, which is printing V as a system.out.println statement, and which is also having another method test, and that is coming from the class X, which is abstract class, and we have extended it, so we can override the method over here, and I'm overriding that, and I'm just printing test. Okay, and in my manager class I'm creating one object of the class V, and I'm accessing v1.test. So test is a non-static method of the class X, and I'm extending that class in my V class, so that I can create an object and access the method. Now the funda is over here that in abstract class we can keep n number of definition block. Okay, here I have defined only one definition block. You can define n number of definition block also. Constructor is one of the definition block. Constructor is over here is also another definition block which I have used. If you don't keep them, compiler will keep by default with no argument. So if you are suggesting that okay, I'm not gonna keep my default constructor in my abstract class, so don't worry, compiler will keep it for you with a default constructor and with a no arg constructor. Now if we are keeping a constructor, then we can't create an object of the current abstract class, so constructor will not execute. Now it is a pretty simple thing that we have seen that in previous tutorials, that we can't create object, because if we are creating object, then compiler will have its own default constructor with no arg, so it will call it will doesn't know to how to call or something like that. Now if we are creating or defining a default constructor, then we can't create an object of that particular class. Now so we will make subclass and it would be concrete. So here also I have defined one subclass V, which is extending X. Now we can create the object of class V, and through that we can have the method default constructor method X, and also the test method can be overridden in your class, so we can access those method or something like that to our object of our class V. So it is also very possible. Now constructor executes when we create an object to current class, or when we create an object to subclass under constructor chain. So constructor chain will be created, and for that you can just access the default constructor through that, and we can create object of the current class or the subclass. Through that, constructor chain will be created and we can access those methods. So this is the most fundamental area of abstract class, and this is the end of this abstract class tutorial, and I hope you have liked it, and thanks for watching, and thanks for understanding also. I hope you are getting some knowledge, and if you are having any problem, you can write in our Facebook page, and also you can leave your comments over the video section, and thanks for watching and have a